Welcome to STEM Professionals. In this video, we will discuss the problems and conceptual exercises of Chapter 2 from the book James S. Walker. So let's start with the video. So here in this question, we are given with this velocity versus time graph for a car which starts from rest and moves forward 22 meters in 8 seconds and then comes to rest. Now there are three parts that we need to solve. In the A part, we have to find the distance covered by the car in first 4 seconds of its motion. Now this is a VT graph. Now one thing we studied, that the area under the VT graph gives the total distance traveled by the car or by the body. So the total distance traveled by the car would be equals to the area of this section. This total area would represent the total distance. So let's do one thing. We find this area and the total distance covered by the car is 22 meters. Then we're going to equate this total area with 22 meters. And we get one value which is very important, that is the velocity at this position, this one and this one. This is the same because here the velocity remains same. Now the area would be, let me do one thing, we can divide it into three sections. This is section 1, this is section 2, and this is section 3. Now the area of section 1 would be 1 over 2 height divided by base. Height we have V, this height is V, multiplied with base. So this base is 4 minus 0, which is a 4. Now plus, now this area would be length multiplied with height. Now length we have V, velocity, this is the length, multiplied with width. This is the width, which is 6 minus 4, which is equals to 2. So V multiplied with 2. Now plus the area for the third section would be half multiplied with height multiplied with base. So height we have V, and base we have 8 minus 6, which is 2. So this total area would be the distance which we are given to be 22 meters. So here we have only one variable, which is V. We can calculate it easily. So 22 is equals to, this would become 2V plus this is 2V, and this 2 will cancel. I did a mistake here, this is V here. V, because the height is V here, not 4. So this is V, this 2 and this 2 will cancel, we'll get V. So 5V is equals to 22, or we can write that V from here comes out to be as 4.4 meter per second. So this is the velocity of the car at this point, and this is the same velocity at this point because during this time interval the velocity is constant. Now we can solve all the parts very easily. Now in the A part, we need to calculate the distance traveled by the car in the first 4 seconds. Now the distance traveled by the car in the first 4 seconds would be area under this curve. So this area would be equals to, let me represent it with x1. So this would be half multiplied with base multiplied with height. So base we have 4 minus 0, which is 4. This is 4 meter, multiplied with height. Height we have V, which we have calculated to be 4.4. So 4.4 meter per second. So this would be equals to 8.8 meter. So this is the distance traveled by the car in the first 4 seconds. Now next, in the B part, we have to calculate the distance traveled by the car in the last 2 seconds. So this is the last 2 seconds from 6 to 8. So this area would represent the distance traveled by the car in the last 2 seconds. So let it be represented with the x2. So half base multiplied with height. Now base we have 8 minus 6, which is 2. So 2, sorry, this is second here, not meter, and here also this is second, multiplied with the height. So height we have 4.4 meter per second. So this would be equals to 4.4 meter. So this is the answer for the B part. Now finally the C part, where we have to calculate what is the constant speed V during the middle portion of the motion. So this is the middle portion, and here the velocity V we calculated to be 4.4 meter per second. So this would be the answer for the C part. So here the question is saying that suppose you are using a video to analyze the motion of penguins as they slides from the ramp. So there are three ramps: ramp A, ramp B, and ramp C. Now the distance traveled by the penguin on ramp A is 4.09, and time it took to cover this much of distance is 2.19. Similarly, for the ramp B, the distance covered is 1.96 and the time taken is 1.08 seconds. And for the C ramp, the data is also given. Now, there are two parts in this question that we need to solve. In the A part, we have to find the magnitude of the penguin's acceleration for each ramp, and we can assume that acceleration is uniform throughout the motion. So let's try to solve the A part first, and then we can proceed with the part 2. Now we are given the distance and the time. So for that we can use this equation: x is equals to x naught plus v naught t plus 1 over 2 a t square. Since time and displacement is given, that is why we are using this equation. And the initial velocity is 0 because it starts from rest. It is clearly written here that it starts from rest. So this v naught would be 0. And initial position x naught, we can assume it to be the origin. So x naught will also be 0. So from here we can write that the position x is equals to 1 over 2 a t square. And from here we can write that acceleration would be equals to 2 times x divided by t square. Now we'll be using this equation for ramp A, B, and C. Okay, so for ramp A we can write that acceleration A would be equals to 2 times x A divided by t A and its squared. Now distance x A we have 4.09 for ramp A. So this is 2 times 4.09 meter divided by time it took to cover this much of distance is 2.19 seconds. So 2.19 seconds and it's squared. Now we can solve this by using our calculator, and we'll get the answer to be 1.71 meter per second squared. So this is the answer for the A part. Now next we have to solve the B part, where same thing, we have to find the acceleration for ramp B. So we can write this is for B case. Now this time AB, this will be equals to 2 times xb divided by tb and its squared. Just use this equation for ramp B. So is equals to 2 times, now xb for ramp B is 1.96 meter. So 1.96 meter divided by time is 1.08 second and its whole squared. So this would be equals to, you can use a calculator to solve this, and this would be equals to 3.36 meter per second squared. So this is the answer for the B case. Now for the ramp C, we can use the same equation. So AC, this would be equals to 2 times xc divided by tc and its squared. So 2 times, now xc we are given to be 1.08. So 1.08 meter divided by time is 0.663 seconds. 0.663 seconds. So this would be equals to 4.91 meter per second squared. So this would be the answer for the C case. Here we can observe that for ramp A, the acceleration is minimum. For ramp C, the acceleration is maximum. Okay, now next in the B part, we have to determine the angle inclination. This is theta here, above the horizontal for each ramp, assuming that acceleration for part A are in close agreement with the formula A is equals to g sine theta. So this formula will derive in the later chapters, but for as of now you can assume that that in this kind of situation acceleration is given by this formula. Okay, so this is the B part here. Now acceleration is given by A is equals to g sine theta. Now what we have to find this angle theta for ramp A, B and C. Okay, acceleration we calculated for ramp A is 1.71 meter per second squared. So we can put it here, 1.71 meter per second squared. Now this g I can take to the left side, and the value of g we know, it is acceleration due to gravity. Its value is 9.81 meter per second squared. So this would be equals to sine theta. So from here we can write that sine theta will be equals to 0.1743. So from here theta would be equals to sine inverse 0.1743, which will be equals to nearly 10 degrees. So this is the answer for theta A. This is for the ramp A. Now next we have to find theta B for ramp B, and for that we can use the same equation, this one, but this time for ramp B. So AB, this would be equals to G sine theta B. So from here we can write that sine theta B, this would be equals to AB divided by G. Now acceleration AB we calculated to be 3.36. So this is 3.36 meter per second squared, divided by G is 9.81 meter per second squared. Now from here the angle of inclination theta B will be equals to sine inverse 3.36 divided by 9.81, which will be equals to nearly 20 degrees. So this is the angle of inclination for ramp B. Now final for ramp C. So theta C, we can directly write this time, theta C would be equals to sine inverse, this is AC divided by G. AC we calculated earlier, 4.91, sine inverse 4.91 meter per second squared, divided by G is 9.81 meter per second squared, and this would be equals to 30 degrees. So this is theta C. Now we can show it on the figure also. So this is I'm just drawing the ramp A first. So this is ramp A, and this theta A is, the calculated is 10 degrees. So this would be 10 degrees. Now next we can draw ramp B. This is a little bit higher, just double of this number. So theta B would be 20 degrees here. Now finally the ramp C. So ramp C we have 30 degrees. So this angle theta C we have 30 degree.